Hello!
Hi!
This is Jenny,
And I'm Chrissy.
Today we're going to learn about
Intermediate value theorem, which is on section 2.7. So, there once lived a flamingo. Suppose that this flamingo can fly. It flew and flew and actually flew 15 meters in 10 minutes.
the intermediate value theorem states that if f of x is continuous on a closed interval from a to b, and if f of a is not equal to f of b, then for every value m between f of a and f of b, there exists at least one value c that is included in the open interval from a to b such that f of c equals m.
Got it? So, how does this apply to our original question?
The flamingo example illustrates the theorem very well, since the flamingo started its flight from A and then ended in B. So the A would be 0 in this case, and f of A will be f of 0 or 0. B will be 10 minutes in this case, and f of B or f of 10 will be 15 in this case. So if there is a value m, function value m, that lies between 0 and 15, then it's going to have a value c that will yield m as its function value between the open interval from a to b.
True. So, why is it continuous on a closed interval? Can it be open interval?
Yes, good question. The theorem states that it should be continuous in a closed interval, but however, if it is continuous in an open interval, then this situation might happen where there's a discontinuity at a. Here, the f of a value will equal 1, and f of b value will equal 6. And this part, where there are y values that don't have x values between the open interval from a to b, will not yield the theorem. That is why we need a closed interval and a function that is continuous on that closed interval.
Ah, I get it. So,
we're going to solve a problem here. Show that g of t, which is equal to t squared times tangent of t, takes on the value of 1 over 2 for some t in the closed interval from 0 to pi over 4. How should we solve this?
okay, so we should first state that g of t is continuous because t squared is continuous and tangent t is also continuous.
In that interval.
So overall, yes, g of t is continuous in this interval. So then we need to solve g of 0. Substitute 0 for t, which yields thus it gives us the result of 0. G pi over 4 equals this. So we can approximate pi square over 16 with a calculator,
Which comes out at
as 0.6168.
approximately. So because g of 0 is 0 and g of pi over 4 is approximately 0.6168, since 1 over 2 lies between 0 and 0.6168, we can assume that the value t, the special value t that yields 1 over 2, does lie in this interval between 0 and pi over 4.
True. Mystery solved.
Now we are going to move on to a special case of the intermediate value theorem, which is called the existence of zeros.
So, it says if fx is continuous on the closed interval a to b, and if fa and fb are non-zero and have opposite signs, then fx has a 0 in the open interval of a to b. We're going to talk about bisection method.
bi means 2, we can assume that this method deals with cutting a section in halves. This is a question that deals with the bisection method. Show that f of x, which is equal to cosine of x squared minus 2 sine of x over 4, has a 0 in the open interval from 0 to 2. Then locate the 0 more accurately using the bisection method. What we have to do here is to come up with a table of values. Since the interval was from 0 to 2, although it is an open interval, we should start with 0 and 2. The function value of 0 would be 1, and the function value of 2 would be approximately negative 0.7857. Now, we're going to bisect this interval and come up with the middle value, which is 1. The function value of 1 is approximately negative 0.2029. See that this value is negative, while this value is also negative, while the f of 0 value is positive. Therefore, we can assume or presume that between 0 and 1, there will be a value that will yield the 0. So we bisect this interval again. We go to 0.5, and we learn with our calculator that f of 0.5 approximately equals 0.5208. Now, since this is positive, and since f of 1 is positive, while f of 1 is negative, while f of 0 is positive, we know that there is a 0 that lies between 0.5 and 1. So we bisect this interval again, and we go to 0.75. And we have the function value of approximately 0.16256. Since this is positive, since this is positive, and since this is negative, we know that there will be a 0 definitely between 0.75 and 1 on the x-axis. So we move on to another table that is more detailed.
Continuous.
We have another bisection here where the value 0.875, which lies between this and this, yields a function value of approximately negative 0.0231. This is negative, and this is positive. So finally, we can conclude that there will be a 0 between 0.75 and 0.875 here.
So, well, this can go on if you want a more accurate answer, but we'll stop here.
And again, this is a question that makes use of the existence of zeros, which is a special case of intermediate value theorem. Now we will move on to another question. This question states that we should draw a graph of a function f of x with the above-mentioned property, which has jump discontinuity at x equals 2, yet does satisfy the conclusion of the IVT on the closed interval from 0 to 4.
Okay, so how do we solve this, Jenny?
Well, we can come up with a graph that goes along with this property. This is such a graph. While this graph is not continuous from 0 to 4, as stated in the property, it does satisfy the IVT because at x equals 2, there's a jump discontinuity. F of 2 is 3, while the left-handed limit of 2 is 2. The right-handed limit at x equals 2 is 3, so there is definitely a jump discontinuity. However, since we are only dealing with the endpoint values, we know that f of 0 is 0 and f of 4 is 1. So the y values that lie between 0 and 1 have all corresponding x values in the open interval from 0 to 4, which satisfied the IVT theorem, even though there is a discontinuity in this interval.
True. Okay, so we go to number question 25.
Which is our last question for the day.
Assume that fx is continuous, and that fx, which is bigger than or equal to 0, and smaller and equal to 1 for the closed interval 0 to 1. Show that f of c equals c for some c in the closed interval 0 to 1.
So we have this graph of f of x. Now, what we have to do first is to define a new function.
So, the question is d of x, which is equal to f of x minus x, is continuous?
Well, first of all, I think we should look back at why d of x is this way. The question itself states that f of c is equal to c for some special value c. Now, what we've done is that we've moved the c from the right side of the equation to the left side, coming up with this new function, d of x equals f of x minus x. As Chrissy said, is this continuous? Well, we know from the question that f of x is continuous for the interval from 0 to 1, which is a closed interval. And we know by instinct and also from our classes with Mr. Cross that x itself is a continuous function.
But more instinctive things.
And since x has been subtracted from f of x, the whole function is continuous due to the law of continuity.
True. So, what are we trying to find here?
We're trying to find whether d of 0 and d of 1 are positive or negative, since 0 and 1 are the endpoint values for our x value interval, which is a closed interval from 0 to 1. So we know that d of 0 is f of 0 minus 0, according to the function's definition. And from the graph, we know that f of 0, which is larger than 0, minus 0 will be positive.
True.
Therefore, it is positive.
D of 1
will equal f of 1 minus 1 according to the function's definition. And from the graph again, f of 1, which is less than 1, minus 1 will be negative. So this will yield a negative function value. Since d of 0 is negative and d of 0 is positive and d of 1 is negative, we know that there will be a 0 or a special c that will yield 0 between 0 and 1. Now, an open interval. So, according to the existence of zeros theorem, which is a special case of IVT, we know that d of c, which is equal to f of c minus c, will equal 0 at some point. And here we can move the c to the right side of the equation, yielding this, which the question wanted. So yes, indeed, the special value c exists between 0 and 1.
That was our last slide. The end. The flamingo is winking at you.
Thank you.
Bye. It states that assume that fx is continuous and that fx that is bigger than 0 and same with 0 and smaller than 1 and equal to 1 for which yields 0, and g pi over 4, which yields pi square over 16.
Pi square over 16 can be approximated with your calculator. Okay, this is testing.
Yeah,
hey, but where did we put the...
Which is, of course, pi square over 16.
And this can be approximated by your calculator. The value is actually